Hey, Muso here. What's the difference between speed and velocity? I don't know. Let's talk about it. Speed versus velocity. All right, so kind of just as was the case with distance versus displacement, you probably can guess one of these guys is a scalar term, one of these guys is a vector term. Turns out speed, yep, that guy right there, that's your scalar term. What does that mean? That means speed only requires quantity. Direction is not important for speed. We don't care which way you're going. Another way of thinking about speed is the best way to define it, I think, is this. It's simply telling you how fast an object is moving. That's it. Doesn't tell you where it's going, doesn't tell you where it's going to finish, nothing to do with displacement. Literally just how fast is it moving. Okay? Whereas velocity is a vector term. Yes, that means it needs both magnitude or quantity and direction. We need both of these guys. Magnitude and direction are very important for velocity. You need to know not only the magnitude of how fast it's traveling, but it will also be telling us where it is going, the direction it is traveling in. Very, very important. Okay? Before I get too far ahead, there are a few terms that we are going to be talking about in here. Average speed or velocity, and instantaneous speed or velocity. Average basically is taking the entire trip into consideration. So if we're in a car, which I will draw as a box with fancy wheels because that's the extent of my art, and that car is traveling, let's say it starts off at 10 meters per second, and then it increases in speed to 20 meters per second, and then it eventually stops, and then it goes back, and then it goes forward and up and down in speed and all over the place, just like a typical drive, right? If, I wanted to know on average how fast I was going, all I have to do is take my total distance and my total time, divide it out, I know my average. However, if at any moment in time while I was looking down at my speedometer, I will probably see that my actual speed is different than maybe my overall average. And that's the term instantaneous. So, try not to make this, let's see, instantaneous, and that kind of sounded funny. Try not to make this too complex here, okay? Average is the entire trip. Instantaneous is at any one instant, okay? It's really that simple. When we go to write our equation out, there will be a subtle difference between the way we write it out, and I'll get there when I get to that in a moment. Okay, so again, speed is the scalar term, velocity is the vector term. For both of them, your variable is the letter V. And here's where I'm going to just tell you the difference between average and instantaneous. When we're talking about instantaneous speed or velocity, we simply put V. Maybe it'll be the velocity at the instant in time position 1. Or maybe it'll be my initial velocity. Or maybe it'll be my third velocity. Okay, it doesn't matter. At that instant, at that moment, that's the velocity. However, if we're talking about the entire trip, or we're talking about maybe this average speed of throughout multiple positions, we are going to put a bar over the top. That bar, that's not optional. Very important. You must include it. That bar tells us that we're talking about average and not instant. Please make sure you put that bar in there if we're talking about average. Okay? So, actually, I'm not going to erase the whole thing. Let's leave it like that. The variable is V. Your unit is the meter per second because speed and velocity is a quantity of distance or displacement over a quantity of time. Your standard unit for distance and displacement is the meter. The standard unit for time is the second. So the standard unit for velocity or speed is the meter per second. My equation will be the same for both. It's going to be very difficult to know for sure just by looking at the equation if we're dealing with speed or velocity. Because remember that variable is V for both. We're not putting an S for speed. So your equation for speed and velocity on average, so average velocity is change in D over T. And I think it's really important to make sure you put that change, that delta symbol in there. That delta means change in, and it does imply that the object is moving. If there was no change, then this would be 0, right? Now, here's the biggest difference between whether or not we're dealing with speed or velocity. This d could mean distance or displacement, and it really depends on, well, it depends on what your goal is. If you're trying to measure speed, then you're going to use distance, and if you're trying to measure velocity, then you're going to use displacement. Let's go through an example so you can understand what I'm talking about a little bit better. And I'm going to go through and we're going to look at that track example that we did last time for distance and displacement. So I'm traveling around a 400-meter track, and I complete one lap at a blistering pace of 60 seconds. Now, some of you track runners at home are probably laughing at me saying 60 is nothing. At least for dudes. A lot of competitive dudes can run a lap in under 50 seconds. I am going to say 60 seconds. And for me, that is impossibly too fast. No way I can do that. So we complete this one lap in 60 seconds. My question to you is, what is the speed and what is the velocity? Let's look at the speed first. Let's break down what we know. We know the distance is equal to 400 meters. That's one lap. And we know the time is 60 seconds. And I want to know, what is my average speed during that one lap? So we're going to set it up. Average speed is change in distance over time. See, I'm writing a list out equation. Now I'm going to sub in those numbers. My change in distance is indeed 400 meters. I completed one whole lap, and that time was 60 seconds. Let's go ahead, use our calculator, and figure out what this is. So I'm just going to do 400 divided by 60. I'm going to find out that I am cruising at 6.67 meters per second. That's pretty fast for a human being. Definitely pretty fast for Muso. That's pretty good. Notice how it doesn't matter which way I'm going. This isn't saying north, east, south, or around in a circle. If I were just to cover this up and say, hey, look at that. This guy is traveling with a speed of 6.67 meters per second. I don't know where I'm going. I just know how much ground I'm covering in a given second. Velocity. Well, you think, well, isn't it the same? Remember, average velocity is going to be displacement over time, or change in displacement over time. What's the displacement in this race? Remember from last example, that's one entire lap. The displacement is how far a place from where you started. If you finish and start at the same spot, the displacement is 0. That means your average velocity is 0 over 60, which is indeed 0. I know, it's crazy, but in this example I just gave you, your average velocity was nothing, and your average speed was 6.67 meters per second. Right? Kind of confusing, I know. Here's the deal. Early on in physics, you need to know the difference between speed and velocity. You need to recognize that this is distance over time. You need to recognize that this is displacement over time. But in reality, really more or less as soon as we get out of this initial chapter, we're going to use these terms interchangeably. And you're going to use these terms interchangeably in real life, and you're going to use them interchangeably in advanced levels of physics. In a testing environment where you need to be very clear on the difference between the two, make sure you know speed is quantity only. Velocity is quantity and direction. But in reality, they mean the same thing. Got it? I hope this helps. All right, that's it. Thank you.